Hello, and welcome to another edition of Ask the Professor. This is a crowd-driven feature. We're dependent on you for the questions that we answer. We never seed our own questions into the mix. We're also dependent upon you for funding to keep our work in production. So please visit the website, that's johnrobson.ca, and click the Yes, I'll Help button if you haven't already. And if you have, thank you for your support.
All right, here's a question from Len. He says, you're going to like that one. If the planet stopped using fossil fuels right now, by how much would the planet cool? I think you're allowed to say, I'm not sure, but go for it.
I'm not going to say I'm not sure. I'm going to say I have no idea, and nor does anybody else. One of the critical things to understand in the debate about global warming, or anthropogenic climate change, or whatever you want to call it, is that the climate of the planet Earth has been unstable, massively unstable, throughout its known geological history. And there are things that we do know. For instance, we know that over the long run, over the last 500 million years, global temperature, to the extent that we can figure out what it was, and atmospheric CO2, to the extent that we can figure out what that was, simply don't correlate. They do not move together. CO2 is not driving temperature. We know this again when we look, for instance, at the coming of the ice ages. Which ones? There have been several in the course of the Earth's history, but the ones that started about 2.8 million years ago, on a planet with atmospheric CO2 considerably higher than it is today, the planet suddenly went into a series of advances and retreats of glaciers to an unusually, though not unprecedentedly, cold period. But we don't know why it did that. We can come up with explanations after the fact, but we can't use them to make predictions. We can't even understand the pattern of glaciation and retreat of the glaciers. There are regular cycles, it seems, 41,000 years, and then suddenly it switches to 100,000, but we don't know why it switched. There's also strong evidence that although temperature and CO2 will move together as a small wave on top of a big wave, it's temperature that's driving it. It's leading the dance, not CO2. When the planet warms, the oceans give off more CO2. When the planet cools, the oceans absorb more CO2. So we have no idea what the planet is going to do if we do not change our behavior. We do not know if the Holocene, the period we're living in since the last retreat of the glaciers, is about to come to an end. On geological terms, if nothing sudden and weird happens, it seems, the interglacials are about 10,000 years long. We probably are due for a cooling. We also know that the sun is going to a period of less activity, and that also portends a cooling. So the chances are that the planet's going to cool anyway. But we don't know by how much, or when, or why. It does experience sudden warmings, like the one that ended the last glaciation, which nobody can really explain. So we can't explain or predict when the next one will come. So we have no idea what's going to happen if we don't change our behavior. We also have no idea the extent to which our emissions of CO2 are altering atmospheric CO2. The planet has been warming since the reign of Queen Victoria. It certainly was warming in the latter part of the 20th century. The sun was as active as it's been since the medieval warm period, and this seems to have caused more CO2 to be emitted. Remember, nature doesn't distinguish between human CO2 and the natural kinds, like ours is CO3, or it tastes bad, or it's plasticky, what's this? We have no idea why atmospheric CO2 has risen, except it's probably in response to the warming, not causing it. So we don't know what CO2 would do even if we weren't producing it. Therefore, it is impossible to generate anything other than gibberish on the subject of what would happen if we stop producing CO2, except if you insist upon observing what we don't know. How little we understand changes in climate, which are, in the technical sense, mathematical sense, chaotic. That is, it's nonlinear. It cannot be modeled using equations and solved through algebra, as we have done so much fruitful work in things like chemistry and physics. It doesn't work with climate. It really doesn't. Is the Earth cooling? Very possibly. Why is the Earth cooling? We're not really sure. What can we do about it? Nobody knows. Very likely nothing. Climate is so big and so complicated that any attempt to intervene, if it didn't produce no effect, would likely produce an unintended and undesirable consequence. Which is why so many people say what we must do is be prepared to adapt. To develop technology in such a way that whether it heats or cools, and a warmer planet, by the way, is not inhospitable to life by any means. Both the great flowering of the mammals and before that the age of the dinosaurs, the Earth was a lot warmer than it is today. What's bad is sudden transitions, up or down, and cold. Cold is what kills off species. Cold is what devastates ecosystems. The Earth was a biologically impoverished place during the ice ages compared to what went before. So we need to be ready to adapt. But the answer to your question, Len, is nobody knows how much the Earth would cool or even whether it would cool if we stopped using fossil fuels. And anybody who does has failed entirely to come to grips with the science. We'd like to know. It's scary that we don't know. We don't know if the glaciers are coming back. That's a terrifying prospect. But the fact that something is unpleasant doesn't make it less real or less likely. And that includes when it comes to this critical scientific ignorance that we have about basic climatic processes and therefore about their outcomes.
All right.
So have a nice day, unless nature has other plans.
Right. Thanks for that. Folks, if you would like to play along and ask your question of the professor, go to the URL on the screen and everything there will be explained. Thanks and see you next time.